ఆ చదువులమ్మ నేరుగా ప్రతి ఇంటి గడప చేరగా మీ భవితకే భరోసా దూరదర్శన్ వేదికగా తెలంగాణ రాష్ట్ర ప్రభుత్వ సహకారాలే ఉండగా హాయిగా మన చదువులు షురు అదే డిజిటల్ గురు అదే డిజిటల్ గురు.
Hello my dear budding scientists, today we are here to know about acids and bases. In the last class we have discussed about what are acids and what are bases, what are their physical and chemical properties, and how to know whether a given substance is an acid or a base. We have used olfactory indicators like onion, and we also have used visual indicators like methyl orange and phenolphthalein, and we also used litmus papers. A base turns red litmus paper into blue, and an acid turns blue litmus paper into red. And we also learnt the reaction of acids and bases with metals, metal oxides and metal carbonates. In today's class, we will know about the strength of acids and bases. When can we call an acid a weak acid, and when can we call an acid a strong acid, and how can we determine given base is weak or strong. So, let us know about the strength of acids and bases. Before that, let us know about the acids. Let us know what is the common feature in acids. Children, let us look at this visual. What do acids have in common? Sulfuric acid H2SO4, hydrochloric acid HCl, hydrobromic acid HBr, nitric acid HNO3, phosphoric acid H3PO4, acetic acid CH3COOH, hydrofluoric acid HF. So, when we observe, when we analyze, each and every acid has the element hydrogen. So, hydrogen is present in each of these acids. So, acids in common have hydrogen in them. In the last class, when we have done an activity of reaction of acid with a metal, then hydrogen gas is evolved. That implies that all the acids have hydrogen in them. Let us once again do another activity which says that hydrogen ions are present in acids, and similarly OH minus ions are present in a base. Let us do an activity to show that hydrogen ions are present and are common in all acids. Children, look at the experimental setup. In a 100 ml beaker, 2 electrodes are taken and they are connected as shown in the figure, and the beaker is filled partially with dilute hydrochloric acid solution. One electrode is connected to a battery, whether it is an AC plug or a DC battery, you can take either of them, and the other electrode is connected to the bulb. When the circuit is closed, the bulb glows. That implies current passes through the circuit. When the current passes through the circuit, the bulb glows. How does the current pass through the circuit? The process of electrolysis of acid solution is done. That implies HCl is dissociated into H plus and Cl minus ions. H plus ions contribute to the conduction of electricity. Through the acid solution, electricity is conducted and the bulb glows. The acid solution in water conducts electricity due to the presence of H plus ions. HCl, when it is put in distilled water, then it dissociates into H3O plus and Cl minus. H3O plus is hydronium ion. How do we get hydronium ion? When HCl dissociates into H plus and Cl minus, each H plus ion is associated with 4 to 6 molecules of water to form H3O plus hydronium ion, and this hydronium ion contributes to the conduction of electricity in acid solution. Similarly, the base solution in water conducts electricity because of the presence of OH minus ions. Let us take the base sodium hydroxide, NaOH. When it is diluted, then it dissociates into Na plus and OH minus ions. Because of the presence of OH minus ions, the base solution also conducts electricity. When the same experimental setup is taken, then the bulb glows in the presence of OH minus ions. Now, let us know what do we understand by the term alkaline. We know that base and alkaline substances, we know that the base solution and alkaline solution are synonymous words. But be careful, all bases are not alkaline, but all alkaline solutions are basic in nature. Let us know what is an alkaline substance. Bases which are soluble in water are called alkaline. All bases are not alkaline, as all of them do not dissolve in water. Children, let us know what do we mean by a strong acid and how can we make it a weak acid. What do we mean by dilution of acids or dilution of bases? Now, for example, the solution in the bottle is concentrated HCl solution, whereas the solution which is mixed with distilled water is dilute HCl solution. Mixing of acid or base in water is called dilution. So, this is concentrated HCl acid and this is dilute HCl acid. Now, let us understand the term dilution. Dilution is mixing of acid or base in distilled water to reduce its concentration. How do we term dilution of an acid? That is decrease in the concentration of H3O plus ions, that is hydronium ions or hydrogen ions in a unit volume. What do we mean by dilution of a base? It is decrease in the concentration of OH minus ions in a given unit volume. Dilution of acids and bases. Once again, let us look into it. Mixing of acid or base in water is called dilution. This will decrease the concentration of H3O plus or OH minus ions per unit volume. Concentrated acid or base when mixed with water generates heat. This process is an exothermic process. Now, children, let us once again do another activity to show that mixing of acid into water, into distilled water is an exothermic process. Exothermic, what do we mean by exothermic process? Exo means outside, thermic means heat. Giving out heat is called exothermic process. Let us once again look. Now, I have taken a test tube. I will add distilled water, a few ml of distilled water into the test tube. Now, let us take sulfuric acid H2SO4. As we said, this is corrosive, highly reactive, and it should not be used with bare hands. In a dropper, I am taking H2SO4, I am putting a few drops of H2SO4 solution in distilled water. Now, as I touch, heat is being generated, the test tube is now hot. This shows that mixing of sulfuric acid in water is an exothermic process, that is, it releases heat and the test tube has become hot. We have known about what is a common feature of acid And what is the common feature of a base? What is the common feature of an acid? Presence of H plus or hydronium ions. What is the common feature of base? Presence of OH minus ions. Because of that, an acid solution or a base solution conducts electricity. We also have seen what do we mean by a concentrated acid, what do we mean by a dilute acid. Now, we will learn about the strength of acids and bases. What do we mean by a strong acid, what do we mean by a weak acid, what is a strong base and what is a weak base. Strength of acids and bases. Concentrated acid or concentrated base. Concentration of more number of H3O plus, that is hydronium ions or OH minus ions per unit volume is called concentrated acid or concentrated base. If there are more number of H3O plus ions, it is called a concentrated acid. If there are more number of OH minus ions per unit volume, it is called a concentrated base. In contrast, what is dilute acid or dilute base? Decrease in concentration of number of H3O plus ions or OH minus ions per unit volume is called dilute base or dilute acid. Children, as we have seen sulfuric acid, this is the concentrated acid, and when we have mixed it with water, this is dilute sulfuric acid. This is concentrated, it has more number of H3O plus ions per unit volume, it has less number of H3O plus ions per unit volume. Dear children, Sorensen has invented a scale for measuring the concentration or the strength of acids and bases. pH scale, a scale for measuring hydrogen ion concentration is called pH scale. P means potence or power in German language. Sorensen introduced the concept of pH. Children, are you looking into that colorful scale? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So, this scale is calibrated from 1 to 14. 1 to 3, the representation for strong acid, and 4 to 6 is the representation of weak acid, and 7 represents the neutral solution, 8 to 10 represents weak base, 11 to 14 represents strong base. 1 to 6 represents acid on pH scale, and 8 to 14 represents a base on pH scale. pH in acids and bases. Let us look. The hydronium ion or hydrogen ion concentration, if it is more, it indicates pH is low, that implies it is an acid. On the other side, if we see OH minus ion concentration is more, lots of OH minus implies high pH value, that implies the solution is a base. Let us look at the pH scale of various daily life substances we use. 0, acid in the battery is very strong and it represents 0 on pH scale. 1 represents the stomach acid, that is hydrochloric acid. 2 on the pH scale represents vinegar. 3 on pH scale represents orange juice. Orange juice, the pH value is 3. Similarly, tomato has a pH value of 4. When we take black coffee has a pH value of 5. Similarly, urine has a pH value of 6. All these substances are acidic in nature. When we take water, it is neutral, it is neither acidic nor basic. So, it stands at 7 on pH scale. Sea water on the other hand is little bit basic, it has 8 on pH scale, indicating that it is a weak base. Baking soda stands at 9 on pH scale, it is also a weak base. Indigestion tablet, that is antacid, whatever we take when we suffer with gastric problem, it stands on 10 on pH scale. Ammonia solution is at 11 on pH scale. Soapy water is once again alkali and it is 12 on pH scale. Bleach is 13 on pH scale. The toilet cleaner or drain cleaner is 14 on pH scale. So, children, now you have observed what is pH scale and what are the various substances what we use in daily life, what are its levels or calibrations on the pH scale. Tomato juice stands at 5, the toilet cleaner stands at 14. It indicates whether the given substance is an acid, whether it is a strong acid or a weak acid, whether it is a strong base or a weak base. Now, given a substance, how can we identify whether it is a strong acid or a strong base or a weak acid or a weak base? Now, I have with me the pH indicator. If you can see, this rose color indicates 2 on the pH scale, this orange and rose color indicates 2.5 on the pH scale, the orange color indicates 3 on the pH scale, the light green color indicates 3.5 on the pH scale, the moderate green color indicates 4 on the pH scale, the dark green color indicates 4.5 on the pH scale. Now, let us do the activity of determining whether the given solution, where does it stand on the pH scale. I have taken this paper from the pH strip, and now what we will do is we will add 1 drop of sulfuric acid on this pH paper. Let us look at the color. It has changed into rose red color. Did you observe? What does rose red color indicate? Let us look with the pH paper. The rose red color indicates that the pH of sulfuric acid is 2.0. On the pH scale, it is 2. So, sulfuric acid is a strong acid. We have learnt that from 0 to 3. If a substance stands in the pH range of 0 to 3, it is a strong acid. Similarly, we have another indicator, a liquid indicator, an universal indicator, wherein we can check whether the given solution is a strong acid or a weak acid or a strong base or a weak base. See, this red color indicates it is a strong acid, that the pH value is 1, this rose red color indicates the pH value is 2, this orange red color indicates the pH value is 3, the orange color indicates the pH value is 4, the yellow orange color indicates the pH value is 5, the yellow green indicates the pH value is 6, the green indicates the pH value is 7, the bluish green indicates the pH value is 8, the blue color indicates the pH value is 9, the dark blue color indicates the pH value is 10. Once again, let us see the prepared dilute H2SO4 solution pH value. 1 or 2 drops of universal pH indicator, and we will shake it well. After it settles down, let us observe the color. This is rose red in color. As you observe, it has taken the rose red color on the pH scale. This rose red color indicates the pH value is 2. The prepared H2SO4 solution, the pH value is 2. Is the topic of strength of acids and bases interesting? We have prepared colorful liquids. Now, let us know the importance of pH in our daily life. Acid rain, if the value of pH is less than 5.6, it is called acid rain. If the pH value lies between 0 to 6, it is an acid. If the pH value is less than 5.6, then it will be a strong or a moderate acid, and what we get is acid rain. That implies when we test the pH value of a rain, if it is less than 5.6, it implies it is an acid rain. Why do we get acid rains? Because of pollutions. The sulfur oxides and nitrogen oxides present in air are the cause for formation of acid rains. Let us look at the common example of tooth decay. Tooth decay starts when the pH of mouth is lower than 5.5. Why does tooth decay occur? The tooth enamel is made up of calcium phosphate, which is very strong. It is the strongest part in our body. It cannot be dissolved in water, but it is easily corroded with acids. When we eat, the sugar particles or the food particles, they defragment and they produce bacteria, and this bacteria produces acids, and the saliva or the plaque on the tooth will be acidic in nature, and this will damage the tooth enamel. Then what should be done? Immediately after eating, we should brush our teeth with a proper toothpaste, which is alkaline in nature. This alkaline nature of the toothpaste neutralizes the acid in the mouth, and the tooth decay will never occur. Another common example of the pH importance is when we have gastric trouble. Children, in your family, you might have seen people suffering from gastric trouble. For digestion of food, stomach produces hydrochloric acid, but you suffer from indigestion, stomach produces more amount of hydrochloric acid and causes pain. So, to reduce this gastric problem, we use antacids or mild alkali. Now, I have with me milk of magnesia, a mild alkali. Now, let us see how does an antacid act to neutralize the acid effect. I am taking a few ml of distilled water, I am adding few drops of HCl. Just see, I am adding a few drops of HCl. Now, this is the condition of our stomach. Acid is produced, more acid is produced during indigestion. Now, to neutralize, we add the mild alkali of milk of magnesia. Shake well. Now, this test tube resembles our stomach, which has produced more gas, more acid due to indigestion. To this, we have added antacid tablet or mild alkali of milk of magnesia. This is totally neutralized. Another important use of pH value in our daily life is the strength of soil, whether the soil is healthy, whether it is neutral, whether it is acidic or whether it is basic. If the soil is healthy, it should be neutral in nature. If it is an acidic soil, then plants cannot grow well. If it is a basic soil also, the plants cannot grow well. So, to test the pH value of soil, it is important to know whether the crops can grow very well in the soil or not. Plants require a healthier pH range for their healthy growth. Now, children, let us summarize. Let us summarize what are the important concepts we have learned in this session. What we have learnt? We have learnt the common ions that are present in acids and bases. What are they? They are H plus or hydronium ions in acids and OH minus ions in bases. And we have learnt about the conductivity of acids and bases. Acid solution and basic solution are good conductors of electricity, and this is because of the presence of H3 plus O ions in acids and OH minus ions in bases. And we have also learnt about the strength of acids and bases. How did we measure the strength of acids and bases? On the basis of pH scale. And we also learnt about the importance of pH scale in daily life. Children, after learning the strength of acids and bases, the common features, let us have a small follow-up activity. Distilled water does not conduct electricity. Can you guess? Why does it happen? Why the flow of acid rain into a river make the survival of aquatic life in a river difficult? So, I think you might have guessed the whatever the questions that are posed before you. Children, I think the session was very much interesting to you. You have known about the strength of acids and bases and the common ions that are present in acids and bases. For more such interesting topics and to quench your thirst for knowledge of science, we are always with you. Thank you.
ఆ చదువులమ్మ